Good morning, grade 4 pupils. I'm Charmel Jerome Jean Codemus from San Miguel Heights Elementary School, your live streaming teacher for today. Once again, let's get started because I'm happy to share to you another interesting lesson in mathematics. So make sure you have your learning module with you, your notebook and a pen for taking down notes. Use the comment section if you have questions about my discussion. We are now on quarter 2, week 5 of most essential learning competencies. Do you know how to visualize addition and subtraction of fractions? Because for today's lesson, you must perform and master these learning competencies. At the end of this lesson, you should be able to visualize addition and subtraction of similar and dissimilar fraction. And also, visualize subtraction of fraction from a whole number. So now, let's have our review. Match each fraction from column A to column B to its lowest term. You may type the letter of your answer on the comment section. The lowest term of 9/15 is letter D, 3/5. The lowest term of 4/10 is letter A, 2/5. The lowest term of 12/16 is letter E, 3/4. The lowest term of 10/16 is letter C, 5/8. The lowest term of 6/12 is letter B, 1/2. So let us read and analyze this word problem. Tommy and Billy shared a chocolate bar. Tommy ate 5/8 of the chocolate bar while Billy ate 3/8 of the chocolate bar. How much part of the chocolate bar did they eat in all? How much more did Tommy eat than Billy? So, who ate the chocolate bars? Tommy and Billy shared a chocolate bar. What part of the chocolate bar did Tommy eat? Tommy ate 3/8 of the chocolate bar. What part of the chocolate bar did Billy eat? Billy ate 3/8 of the chocolate bar. What does the problem ask you to find? So, how much part of the chocolate bar did they eat in all? And how much more did Tommy eat than Billy? So, how will you solve? How will you solve for the answer? So, we have our solution 1, the fraction chart. So, this is a fraction chart that shows us different ways to divide a whole object like the chocolate bar. So, which of these strips can help us to solve 5/8 plus 3/8? Very good. We can use the strips of 1/8. How much part of the chocolate bar did they eat in all? By using 1/8 strips, we can show 5/8 of the chocolate bar. Then, add 3/8 of the chocolate bar that Billy ate. As you can see, 5/8 plus 3/8 is equal to 8/8 of the chocolate bar. 8/8 is equal to 1 whole chocolate bar. So, the answer is Tommy and Billy ate 8/8 or 1 chocolate bar. Solution number 2, we can use number line. We can also solve 5/8 plus 3/8 using this number line. First, let us show 5/8 of the chocolate bar in the number line. Draw an arrow from 0 to 5/8. Then, let us put another line that passes 3 1/8 from 5/8. So, these 3 lines represents 3/8. We can also get the same answer, which is 8/8 or 1 chocolate bar. We can also illustrate using region. So 5/8 plus 3/8 equals, so 5/8, then add 3/8 equals 5/8 plus 3/8 equals 8/8. Tommy and Billy ate 8/8 or 1 chocolate bar. How much more did Tommy eat than Billy? So Tommy ate 5/8 of the chocolate bar. We can use subtraction of fraction to answer this question. Remember, Tommy ate 5/8 of the chocolate bar, and if we take away 3/8 of the chocolate bar that Bill ate, we can see on this part of the chocolate bar that Tommy ate 2/8 or 1/4 of the chocolate bar more than Billy. Now, let us try using number line to solve 5/8 minus 3/8. Again, first, let us draw from 0 to 5/8. But this time, we will draw a line from 5/8, another 3 lines to the left, going to left, to give emphasis of subtracting 3/8. The arrow stops at 2/8. So, Tommy ate 2/8 or 1/4 of chocolate bar more than Billy. Lastly, we can use region. 5/8 minus 3/8 is equal to 2/8 as shown in this illustration. Tommy ate 2/8 or 1/4 of the chocolate bar more than Billy. Let us have another word problem. Michael jogged 9/10 kilometer while Kerwin jogged 1/2 kilometer. Who jogged longer? By how many kilometers? How many kilometers did they jog all together? First, we need to determine who jogged longer. By how many kilometers? Michael jogged 9/10 kilometer and Kerwin jogged 1/2 kilometer. The illustration shows us that 9/10 is longer than 1/2, so that Michael jogged longer than Kerwin. But by how many kilometers? What can you observe between 9/10 and 1/2? 9/10 and 1/2 are dissimilar dissimilar fraction. So let's try to find out an equivalent fraction for 1/2. So 1/2 is also equivalent to 5/10. So just like 9/10, let us cut this fraction into 10 equal parts. As you can see, 1/2 kilometer is also equal to 5/10 kilometer. This part are the kilometer jogged by Michael more than Kerwin. So 9/10 kilometer minus 5/10 kilometer is equal to 4/10 kilometer or 2/5 kilometer. So Michael jogged 4/10 or 2/5 kilometer more than Kerwin. How many kilometers did they jog altogether? Next, let us find out how many kilometers did they jog altogether. Again, Michael jogged 9/10 kilometer and Kerwin jogged 1/2 kilometer. Again, 9/10 and 1/2 are the similar fractions. So we will change 1/2 to 5/10 kilometer. 9/10 plus 5/10. Let's put one part here. So we can see that all parts of one whole are shaded. So we have one whole bar. How many parts in all are shaded? So there are 14 shaded parts. So 9/10 kilometer plus 5/10 kilometer is equal to 4/10 kilometer. Remember to always reduce it in lowest term. So 4/10 kilometer is also equals to 1 4/10 kilometer or 1 2/5 kilometer. So Michael and Kerwin jogged 1 2/5 kilometer altogether. Problem number 3. Father bought 2 meters of wood in the hardware. If we use 3/4 meters for repair, how long was left of the wood? We can solve the problem by using number line. Let's make a number line using 4 as their denominator. Because in the problem, there is a fraction that has 4 as its denominator. First, let us show how many meters did Father bought. So, Father bought 2 meters or 8/4 meter of wood. Then, draw a line that will pass 3 lines to left side to show subtraction of 3/4. So, as shown in the number line, there are 5/4 or 5/4 meter or 1 1/4 meter left of the wood. We can also use using regions. Again, Father bought 2 meters of wood or 8/4 meter of wood. So, we can subtract 3/4 or 3 parts in this one piece of wood. So 2 meters or 8/4 meters minus 3/4 is equal to 5/4 meters or 1 1/4 meters left of the wood as shown in the region or illustration. Now, for your activity 1, use a number line to find the sum or difference of the following. I will be giving you just 15 seconds to answer. So, number 1, 26 plus 36 equals what? So, 26 plus 3, 6. So let us draw a line from 0 to 2, 6. Then, add another 3 lines to represent 3, 6. So 2, 6 plus 3, 6 is equal to 5, 6. Number 2, 5, 7 minus 3, 7. So 5, 7 minus 3, 7 equals what? So let us draw a line from 0 to 5, 7. Then draw a line from 5, 7 going to 3 lines to the left to represent 3, 7. So the answer is 2, 7. Number 3, 3 pips plus 4 pips. Three pips plus 4 pips. So let us draw a line from 0 to 3 pips. Then from 3 pips, we will pass 3 lines to the right, 4 lines to the right to represent 4 pips. So the line stops at 7 pips. So 3 pip plus 4 pip is equal to 7 pips or 1 and 2 pips. Number 4, 3 minus 1 half. So 3 minus 1 half equals what? Let us identify 3 in the number line by drawing a line from 0 to 6 halves. 6 halves is also equal to 3 or 3 whole numbers. Then, draw a line from 6 halves going to the left to show 1 half. So the answer is 5 halves or 2 and 1 half. Last number for this activity, 4 minus 2/3. So 4 minus 2/3. Let us identify 4 in the number line. 4 is also equal to 12/3. 12/3 going to the left. So let us draw 2 lines. A line going to the left. So to represent 2/3. So the line stops at 10/3. So 4 minus 2/3 is equal to 10/3 or 3 and 1/3. For your second activity, use the figure divided into equal parts to find the sum or difference of the given fraction. Again, I will be giving you 15 seconds to answer. Number 1, 6/8 minus 2/8 equals what? You will use this figure. So the figure is already divided into 8 equal parts. So now let us put 6, 8 on this figure. So that is 6, 8 of the circle. Then add or subtract 2 eighths to it. So we will erase or take away 2 parts from this 6, 8. So 6, 8 minus 2, 8 is equal to 4 eighths or 1 half. Next, 7, 20 plus 6 20 is equal to. So use this figure. Again, this figure is already divided into 20 equal parts. So first, we shade 7 parts to show 7 over 20. Then, shade another 6 parts to show 6 over 20. The answer is 13 over 20. Number 3, 3/4 plus 1/8. So let us draw 3/4 and 1/8. So this figure shows us 3/4 and this figure shows us 1/8. So let us put together the shaded part. So again, 3/4 is also equals to 6/8. So 3/4 plus 1/8 equals to 7/8. Number 4, 2/3 minus 1/2. So use this figure. So this figure is 2/3, while this figure is 1/2. So we can change 2/3 to 4/6 and 1/2 to 3/6. So let us subtract 4/6 minus 3/6 equals 1/6. Number 5, 1 minus 7/12. Use this figure. So 1 minus 7/12. So this figure is already divided into 12 equal parts. So as we all know, 1 is also equals to 12 over 12. So 12 over 12 minus 7/12 equals 5/12. So 1 minus 7/12 is equal to 5/12. So remember, to visualize addition or subtraction of fraction, we can use fraction chart, number line, or figure that are divided into equal parts. So for your home learning task or for your assignment, you need to answer the exercises on assessment on page 21 of your learning module for mathematics second grading. So now, let's proceed to question and answer. For your question about my discussion, you may type it on the comment section. I will wait for it. Now, this is the first question. Is there any other way to find the equivalent fraction of the similar fraction? The answer is yes, we can find the LCD or least common denominator, which will be given emphasis in the next discussion. Second question, which is better to visualize? Addition and subtraction of fraction? Which is better to visualize? Visualize addition and subtraction of fraction, number line, or by using region. This is depend on given or how you want to show the illustration or addition and subtraction of fraction. So once again, I'm Sir Mel Jerome G. Nicodemus, your mathematics FB live streaming teacher for the day, giving you this message. A man is like a fraction whose numerator is what he is and whose denominator is what he thinks of himself. The larger the denominator, the smaller the fraction. By Leo Tolstoy. Thank you for listening to our discussion.